Are you interested in developing your own autonomous vehicle system? Statistics show that there are a huge amount of vehicle-related accidents yearly. Current autonomous systems out there are also not performing well enough for us to deem them as road-ready. Moreover, there are relatively few people developing autonomous vehicle systems. We are still years away from having self-driving cars on the road. Thus, we need more people like you to develop autonomous systems in order to reduce the number of road accidents. Even Derek from Veritasium highlighted on the advantage of self-driving cars during the making of this project. Coincidence? But, where do we start? Do you have to design your own simulation environment using perhaps Unreal or Unity? And make your own vehicle model with all the complex vehicle physics? Then make your own map? What about the NPC such as pedestrians and vehicles? Traffic lights also need to be simulated well enough for realism.
Boring! Shut up, nerd!
You will certainly be overwhelmed by the complexities of the autonomous vehicle system since there are too many fields that must be known to be able to implement the system. Introducing iLix. iLix is an autonomous simulation integrated development environment designed to simplify the autonomous development process for developers like you. Simulation cuts development time and cost of autonomous vehicles. It also improves their safety. iLix reduces the need for coding things such as the environment and the vehicle model and makes the development process easier. This is so that the developers can focus on only the most important aspect of self-driving cars, which is the AI system. The simplicity of iLix will result in more people learning about autonomous vehicles and participating in autonomous development, which will allow us as a community to build a more intelligent system so that level 5 autonomous vehicles can be achieved earlier. Thanks to Carla Simulator and some other frameworks, we are able to integrate iLix into a feature-packed development environment that can ease the development process of autonomous vehicle system. iLix website provides an overview of our features. iLix website also provides a forum for users to voice out the problems they have faced. iLexgram provides a social media platform for developers to showcase their AI performance and also for sharing bloopers from AI failures. iLix provides a graphical user interface for you to set up the environment and vehicle model desired. For example, there are several beautiful maps provided for you to choose.
When you first saw
Carla.
were you blinded by its majesty?
Blinded?
Paralyzed? Dumbstruck?
No.
Time of day can be tweaked.
Wouldn't you like to know, Weather Boy?
Weather presets can be saved and then executed later. Weather can also be set to dynamic. The NPC can either be controlled by Carla or by using Sumo. These NPC follow traffic rules and will stop whenever it detects any obstacle in front of it. With Sumo, you are basically a traffic controller on steroids. You can add traffic items such as stop lines, traffic lights, bus stops and various other items using NetEdit. You can make traffic commands in real time like
I, Lelouch v. Britannia, command you.
Warning, collision, 20 seconds.
Gosh, you sound like my mother. Hold up, everybody stop, everybody.
Warning, all stop.
There are also a variety of vehicle models you can select. Don't like the maps and vehicles? You can make your own or edit existing maps and vehicles by using the UE4 and Carla compiled from source code. Don't have a decent GPU? You can also disable rendering and work on just the simple 2D map of the environment. iLix also provides LAN-based multiplayer features for developers to come together and train multiple agents simultaneously. The Carla Simulator provides a wide variety of sensors such as radar, LiDAR, depth camera, RGB camera, GPS, IMU sensor, lane invasion detector, obstacle detector for you to develop your ideal autonomous vehicle. There are several navigation means Carla Simulator provides, such as a 2D map of the surrounding near the agent, longitude and latitude information, and the X, Y, Z coordinate of your agent with respect to the map's origin. The destination waypoint can be obtained by keying in the road ID and lane ID desired. And from these you can derive the bearing and distance from the agent and the destination. Force and torque can be applied onto any vehicle anytime to train your AI system. Carla Scenario Runner provides you with a ton of test cases such as follow leading vehicle, vehicle turning, vehicle running red light, stationary or dynamic object crossing, no signal junction crossing, control loss. A log will then be provided to show how your system performs under a certain test case. There are sample codes provided for you to learn how the Carla framework works. Some of these codes are agent spawning, sensor initialization,
Damn, son, where'd you find this?
sample agent code, and lane tracking. For gamers, you can have fun driving or walking around the town using Xbox controller or WASD keyboard control and spectate the AI performance.
If you're going hard enough left, you'll find yourself turning right.
The mayhem you cause, such as crashing onto cars or causing any other form of accidents, can improve the realism of the game, similar to real-life infraction events committed by others. Even if you don't like to drive, you can also fly. Just don't overdo it, otherwise you will end up in space orbital. Get it? Join us and start making your autonomous system. Because, together, we can make autonomous vehicles great again.
What a beautiful duet.
お前はもう死んでいる。何